This is question number 4 of homework 5. So this is an example of using the Black-Scholes option pricing model to estimate the value of an asset. So this model is not only useful for pricing options on securities such as stocks and bonds, but also can be used to price real estate, as in this example. You own a lot in Key West, Florida that is currently unused. Similar lots have recently sold for $1,370,000. Over the past 5 years, the price of land in the area has increased 5% per year, with an annual standard deviation of 28%. A buyer has recently approached you and wants an option to buy the land in the next 12 months for $1,520,000. The risk-free rate of interest is 3% per year, compounded continuously. So the question asks you, how much should you charge for the option? So when we look at this question, we try to put the numbers in a framework of the option pricing. So if we pull out our lecture notes, to go to the lessons, session 5, PowerPoint lecture slides. And we can see the option pricing model, the Black-Scholes option pricing model includes basically five different inputs: stock price, exercise price, interest rate, volatility in the stock price, expiration date. So even though we use stock price here, but translating into the setup in this case, we should use the asset price, right? The real estate, the land price in this example. So the formula looks like this. The option price equals this chunk S times N D1. So N here is the cumulative distribution function. That's the probability of a standardized normal distributed random variable will be less than D1. So that's the probability on the left of D1. If you draw a distribution of the distribution of the uniform distribution, the normal distribution, standard normal distribution, minus that. So we just try to put the numbers into these formulas. So I try to solve this question in Excel. So S is the stock price. So as we said, in this example, we should use the land price, right? The land price is have recently sold for, so that's the land price. So that's 170,000. And the second input we need is this, if we S times N D1. So D1 further is equal to natural logarithm of S over E. So the second input is E, and E is the exercise price. So exercise price means that by the time of the maturity, how much the buyer of the holder of the option needs to pay in order to acquire the asset. So in this case, after 12 months, the buyer needs to pay this much. So this $1,520,000 is the exercise price. So that's the E, 1,520,000. And the third input, if we check this formula for D1 again, is R. So R is the annual risk-free rate of return continuously compounded. So go back to the setup. The risk-free rate of interest is 3% per year compounded annually. So this is the annual interest rate and it's compounded continuously. So that means R is simply this 3%. And go back to the formula again. And the fourth input is this sigma. Sigma is the variance, the standard deviation actually. Sigma square is the variance of the stock return. So here is the variance of the land price, land return, appreciation rate. Let's call that return. Putting similar terms for the land price, we should use the appreciation rate for the land value. The variance, the sigma square is the variance of the appreciation rate of the land value in our example. So sigma is the standard deviation of that. So standard deviation over the past 5 years, price has increased 5% per year with an annual standard deviation of 28%. So standard deviation is 28%. 28%. Sigma 28%. A buyer has recently approached you, so a risk rate, we have that. And going back to this formula again, so we have this final input which is required is this T. So T is the time which is in years to expiration date. So that's the maturity basically for the options, and it must be in years. So going back to this example, so the agreement is for the next 12 months. So that means T here, the maturity should be 12/12, right? So that because that has to be in years. So that's simply 1 year. So now we have all the inputs which we need in order to calculate this D1. And D2 basically, after we get D1, we can also get D2 based on the same inputs. So now we have basically everything we need in order to calculate this option value, option price. So first, we try to get D1. So D1 is logarithm. So in Excel, logarithm is ln. That's the natural, if you look at this, natural logarithm of a number. So we ln. You can Excel the capital letter or the lowercase letter, doesn't matter. So you can either put capital letters of ln, or this, like in my case, I just put a small case of ln. Both will give you the same results. So ln S over E, right? The stock price over the exercise price. So that's basically this stock price here over this exercise price, and plus, and I need a open parentheses for this R plus sigma square over 2, and then close parentheses, right? So R is this 3% plus sigma square. So this 28%, I need to square that because that's sigma, and then divided by 2 and close that parentheses, and then multiply by this T. So now I need to add another open parenthesis before this logarithm sign and another closing parenthesis after this T, B5. Because everything needs to divide it by sigma times square root of T. So for that, I add the open parentheses, and it's sigma times square root of T, SQRT, that's the square root function in Excel, and T, and close parentheses for the square root function, and close parentheses for the B4 times this square root function, because we need to divide the product of these two numbers. If you don't have the parentheses, Excel will first divide by this B4, the sigma, and then multiply by square root of t. So that's not what we need, right? Because we need to divide by the product of these two numbers. Or if you don't want to use the open parentheses here or closed parentheses there, you can also use the divide sign for both. So you divide for B4, which is sigma first, and then you divide by square root of the B5 t, and then that will give you the same answer. So that's D1, and D1 equals that, and D2 will be based on D1 minus sigma times square root of t. So sigma times square root of t, and that's my D2. So, and then we need to check this n D1. So n is the CDF function, that probability of a random variable, a standard, which is distributed by the standard normal distribution function that is less than 1 D1. So that's the meaning of this D1 ND1. And in Excel, that function is simply the n. So let me put ND1 first here. So that function is n norm s dist. Norm s dist. So that's the this function returns. If you read this instruction here, returns the standard normal cumulative distribution has a mean of 0. Standard normal means that the mean is 0 and the standard deviation is 1. So that's what the standard normal means. And that's exactly what we need. And so that's ND1. Just click on this number. Oh, I need the open parentheses and D1, close that. And that's ND1. And ND2, similarly, that's simply NOMS, norm S dist, and D2. So that's ND2. So now I have the ND1, ND2, and then I can plug everything into this formula for C. Right? The full formula C equals S stock price, which is here, times ND1 minus E exercise price times this E is the base of the natural logarithm, and we can in Excel that function is exp. So it returns E raised to the power of a given number. So E, that's the natural base of the natural logarithm. So that's 2.712818 and infinite number of decimal places. So it's irrational number, right? So, and that's exp. We need to put exp negative, right? Negative r times t. So r times t. So that's my exp value. Exp e to the minus r times t's power, and then multiply by ND2. So that's my final value for the option price. Okay, so now let me go back to so then we need to read the instructions first. Enter your answer in dollars, not millions of dollars. So that's what we did. We put this into the dollars. Everything is in dollars. So the final answer also must be in dollars. Do not round intermediate calculations and round your answer to 2 decimal places. And that's another benefit of using Excel to solve this question, because we don't have to round, right? And we didn't round the intermediate calculations. So the final answer, we need to round to 2 decimal places. And so I can format the cell and keep 2 decimal places, and that's this number 111,292.59. So it's 111,292.59. So let me check my work. Good work. So I'm hoping that using this example, I have showed you how to solve a Black-Scholes option pricing model. Specifically, this is not a typical option pricing for stocks, for the options on the securities, such as stocks or bonds. And this is the option on a land value. So we can also use the Black-Scholes model to calculate the price of such an option.